This is Unit 1, Lesson 5, Absolute Value Equations and Inequalities. And today we're going to be looking at graphing inequalities in two variables, meaning we're going to graph our inequalities on a coordinate plane and shade from there, as opposed to a single variable number line. So by the end, you should be able to graph an absolute value inequality on a coordinate plane. Review from last time. Write an absolute value inequality from a given graph on a coordinate plane. Okay, so graphing absolute value inequalities. Remember that an absolute value inequality is in the shape of a V. All right, you can create a table of values to figure out your points, plot the points and connect them, or you can remember the transformations that we talked about before. So in all of these first examples, I have a table of values written for you, where you're just picking points, you're plugging them in to form your V. However, if you understand how to graph using the shifts and the dilations, in my opinion, I think it's a lot easier. Okay, recall all parent functions, so just the y equals the absolute value of x, start at 0, 0. That is your vertex. That is your center point. So to graph any future absolute values, if I take this point and I shift it around, depending on the transformations happening in my equation, I can very easily plot my new graph. All right, or you can use a table of values where you plug in certain x values. So what's got to be careful of as your vertex shifts, you need to use x values that will reflect that. All right, so let's look at this example right here. I have y equals 3 times the absolute value of x plus 4. Let's first start with any shifts, any sideways or up and down movements. Since I'm adding 4 on the inside, remember when I'm adding inside my absolute value, that's telling me I have a horizontal shift. I'm moving my graph sideways in the opposite direction. So since that says x plus 4, I know my vertex is moving left 4. So I took all these original points from my parent value and I subtracted 4 to come up with some new x values. Okay, so just some more things you've got to think about. All right. Excuse me. Now, I also have a stretch of 3. We'll talk about that momentarily. Okay, so what's happening? It's shifting left 4 and it's stretching 3. So let's look at our graph. All right, here it is. So once again, you could have used your table of values, or you could have realized, hey, here's my original parent function. Okay, if you notice in the parent function, I start at 0, 0, and I'm going up 1 and over 1 in both directions. So I can take that vertex point and I can shift it to the left 4, which gives me this point right here. Now, as opposed to going up 1 and over 1, I can take this dilation factor, the number in front, and think of it like a slope of a line. From this point, I'm going up 3 and 1 to the right. Up 3 and 1 to the right. So it's stretching it up 3 every time. All right, so the height between each point stretches by a factor of 3. All right, so it's making it taller and skinnier. And then I can do it in the other direction, up 3 and 1 to the left, up 3 and 1 to the left. So it's much easier to use this as opposed to your table of values. Once again, of course, you can use a table of values. You have to create your own in order to graph it, or think about your shifts. Let's look at this example next. Once again, you can use your table. You'll notice, okay, inside is a negative 3, going the opposite direction. So I'm going to move right 3, and then I'm going to move down 2. There is no number in front, so I don't need to worry about stretching or compressing it. Okay, so I can go from the center point and shift my graph to the right 3 and down 2. So here's my original center point from this. So always start at the origin, move it 1, 2, 3 to the right, down 2. That is my new vertex. There is no number in front, so I can just use my pattern of up 1 and over 1 to the right, up 1 and over 1 to the left. And that's how I get my V. So recognizing these patterns in the equations makes it so much easier to plot your new absolute value. All right, taking a look at our next one, I have 3 things going on here. X minus 2 is a shift to the right twice. X plus 4 is a shift upwards 4 times. And a negative means I'm reflecting. It's going to be a frowny face absolute value. All right, so same thing. Use your parent function skills. Okay, 2 to the right, up 4, 1, 2, 3, 4. And as opposed to going up and to the right to get my next points, I'm going down, down, down. And there's no number in front, so I'm just going 1 and 1, 1 and 1 in both directions. And there's my V. Okay, so now we're going to add in an inequality. So we're going to graph it the same exact way, except when we add an inequality, we got to think about open or closed. When we looked at a number line, we did open or closed circle, and then where to shade. So same thing here, except we're going to do an open or a dashed line, or closed or solid. Okay, they mean the same thing. And then I've just got to figure out where I'm shading. Am I shading above the V or below the V? So if it's a greater than, it's above, okay, greater than it. If it's less than, it's below. All right, so let's take a look at this example. All right, so I have this graph. Y is less than or equal to the absolute value of x minus 4 plus 5. So to graph the line, the absolute value itself, this is right 4, up 5. So from the origin, I go right 4 and up 5. Notice that's also the vertex, which has the 0.45. There are no negatives or numbers in front of my absolute value. So from here, I'm just going up 1 and 1 to the right, up 1 and 1 to the left. Since the inequality symbol is an equal to, it is a solid line. Since it is a less than, I'm shading below the V. So think about it this way. Look for where your V crosses the y-axis. It's crossing at 6, 7, 8, 9. I'm shading the side that has the y values on the y-axis below that. And I got to shade outside the entire V. As you can see, it's done in blue. All right, my next graph, notice y is not by itself. So we'd still have to first solve for y. So we're going to subtract 3 on both sides and then divide by -1. Okay, so when I divide by -1, I got to flip my inequality, divide by -1 here, and then divide that by -1 as well. Okay, I'm not doing anything inside the absolute value. So now looking at it, I have a shift left 1, let me use a different color, a shift left 1, up 3, and it's flipped. Okay? It's going to be a dashed line, and I'm shading below because it's a less than. So I went left 1, up 3. So that vertex is at -1, 3. There's no number, but there's a negative, so we went down, and it has to be a dashed line because it's the less than. There's no equal to. And a less than means shade below. So once again, look at where your absolute value graph is hitting the y-axis and shade the side of the graph that has the other points that are lower than that on your y-axis. All right, so you pause the video and try a couple transformations on your own. All right, now I'm going to go over them. So this first one on the left, y is by itself, so I'm good to go. I notice that I am moving to the left 2. I am moving down 3, and I have a flip. It's also a dashed line, and it's shading above. It's a greater than. Okay, so it tells me all of those things. So when I look at it, my vertex is going to be at the point -2, -3. All right, and here it is at -2, -3. It's going down with a dashed line, and I am shading above. This one over here, I need to solve for y first. All right, so I have y is less than or equal to -1/2. Take a look at that. Absolute value of x minus 5, minus 3. So we are moving right 5, down 3. It is negative, and we have this 1/2 in there. Don't worry, I'll show you what to do. Oh, also less than and shading solid line. Oops. Okay, so the vertex, since I moved, is right 5, down 3, is at 5, -3. So it's right here. It's going to be a solid line. It's a negative, so I go down and it compresses it by 1/2. So guys, when the number in front of your absolute value is a fraction, it's actually going to make it kind of wider. When the number is a whole number, it's going to make it taller and skinnier. So for the 1/2, remember, treat it like a slope of a line. It's -1/2. I'm going down 1 2 to the right, down 1, 2 to the right, down 1, 2 to the right. And then you've just got to do everything in reverse. Down 1, 2 to the left, down 1, 2 to the left, down 1, 2 to the left. So treat that number like a slope. If it's a fraction, you're going to get wider. If it's a whole number, you're going to get skinnier. Okay, it's solid, and I shade below.